India's river system comprises 14 major basins that dictate the topography of the subcontinent and sustain over 80. To understand the destiny of any drop of water falling on the subcontinent, whether it disperses into a massive agricultural delta or exits through a narrow estuary, we have to map the underlying geomorphological blueprint driving these currents. The structure of the Ganga Basin provides the clearest model of northern hydrological behavior. At its origin point in the Uttarakhand Himalayas, the water emerges from the Gangotri Glacier not as the Ganga, but as the Bhagirathi River. It only officially becomes the Ganga downstream at Devprayag, where the Bhagirathi merges with the Alaknanda. From there, the newly formed river descends from the mountains and breaches the flat northern plains at Haridwar. To accurately map the enormous drainage basin that follows, hydrologists use a strict rule of orientation. Left bank and right bank tributaries are defined entirely by facing downstream in the direction of the flow. Under this rule, the Ganga's left bank absorbs the massive volume of Himalayan runoff. The Ramganga, Gomti, Gagara, Gandak, and Kosi rivers all strike the main channel from the north. This drastically expands the Ganga's width. From the south, the right bank receives its own massive influx, primarily from the Son River and the Ganga's longest single tributary, the Yamuna. The point where the Yamuna finally intersects the right bank of the Ganga is the Triveni Sangam at Prayagraj. Here, the two massive water volumes collide to form a single unified basin structure. This unified channel travels eastward until it hits West Bengal, where the geography forces a bifurcation. The water splits into two paths, the Padma, which flows into Bangladesh, and its major distributary, the Hooghly, which drives south through Calcutta. By mapping these tributaries, we see a footprint covering over 1 million square kilometers. This sheer concentration of fresh water and fertile silt is the exact geographic reason this basin has acted as an unbroken cradle for human civilization. Shifting focus west to the Kailash Range in Tibet reveals a different hydrological mechanism. This elevated region is the origin point for waterways geologically older than the Himalayas themselves. These systems exhibit antecedent drainage. They existed before the Indian tectonic plate collided with Eurasia. As the land pushed upward to form mountains, the rivers maintained their original channels by eroding the rock downward at the exact same rate. The Indus River is a prime example. It flows northwest from Tibet until it violently intersects the rising terrain at the Gilgit Gorge. The water strikes the rock, carves a sharp curve, and is forced into a steep southern turn toward the Arabian Sea. As it descends, the Indus Basin absorbs 5 distinct tributaries: the Jhelum, Chenab, Ravi, Beas, and Sutlej. The convergence of these 5 rivers is what gives the Punjab region its name. Structurally, the Chenab acts as the primary collector. It is the largest of the 5, sweeping up the waters of the other 4 tributaries before delivering the combined payload into the left bank of the Indus. On the exact opposite side of the Kailash Range, the Brahmaputra operates on the same antecedent principles, but flows eastward across the Tibetan Plateau under the name Tsangpo. After traveling over 1,600 kilometers, it collides with the Namcha Barwa mountain peak. The river carves a massive, sharp gorge through the rock, pulling a U-turn to enter India as the Dihang River. Free from the tight mountain gorges, it enters the Assam Plains. Here, the channel widens out significantly, officially adopting the name Brahmaputra before dropping south into Bangladesh. These trans-Himalayan rivers are a direct record of hydrological erosion overcoming tectonic uplift. The resulting high-velocity waterways carry immense volumes of sediment down from the highest peaks on Earth. Moving south to the peninsular plateau, the hydrology is governed by one rule. The Deccan landmass holds a persistent downward tilt from west to east. The water source for this tilted plateau comes from the Western Ghats. This elevated mountain range acts as a primary watershed, capturing the heavy monsoon rains and feeding the downward slope. The largest result of this drainage is the Godavari. Originating in Maharashtra, it travels eastward, carving out a basin area of over 310,000 square kilometers. After navigating narrow gorges in the eastern Ghats, the Godavari hits the coastline, fanning out its accumulated sediment to create a sprawling, highly fertile delta on the Bay of Bengal. To the south, the Krishna River mirrors this behavior. Fed by its major tributaries, the Bhima and Tungabhadra, it traces a parallel eastward journey, serving as a crucial irrigation artery for 4 different states. Slightly north, the Mahanadi initiates from the highlands of Chhattisgarh. It cuts through Odisha, carrying heavy, mineral-rich sediment gathered from the plateau directly to the eastern coast. And furthest south, the Calvary River descends from Karnataka into Tamil Nadu. As it approaches the ocean, its highly bifurcated structure creates a vast agricultural zone, often called the Garden of southern India. Because these rivers flow across a wide, gently sloping plateau, they lose velocity as they near the coast. The slower water drops its suspended sediment, continually building the massive agricultural deltas that feed half the nation. But this continental tilt presents a geomorphological paradox. If the peninsula slopes eastward, the massive Narmada and Tapi rivers shouldn't be able to flow west into the Arabian Sea. The explanation lies in tectonic faulting. In central India, the crust is scarred by the Vindhya and Satpura mountain ranges. The Narmada and Tapi do not flow over the surface of the plateau. They are trapped in rift valleys, deep geological trenches formed where the Earth's crust pulled apart and a central block dropped down between the mountains. The Narmada is forced to carve violently through these constraints, cutting past steep, hard rock formations like the Marble Rocks Gorge. This hard rock channel changes the river's output. Unlike the east-flowing rivers, the Narmada and Tapi gather very little loose sediment, and their deep trenches prevent the water from spreading out laterally. With no sediment and high velocity, delta formation is impossible. Instead, these rivers empty directly into the Gulf of Combat through wide tidal estuaries. The Narmada and Tapi prove that while gravity governs the general flow of water, localized tectonic scarring dictates the ultimate direction. When we zoom out, we see a subcontinent operating on strict, predictable physics. Every river is flowing exactly according to its tectonic programming. Understanding this kinetic energy is how modern engineers determine where to place megastructures. They analyze the topography to find the exact points where hydrodynamic power can be captured and converted into electricity. It is why a 26-kilometer-long structure like the Hirakud Dam was built to tame the wide Mahanadi Basin in Odisha. And it is why the Sardar Sarovar Dam requires a distinctly different design, structurally integrated into the steep, rocky confines of the Narmada Rift Valley to handle the high-pressure western flow. We are looking at 3 distinct frameworks: northern glaciers carving antecedent gorges, eastern gradients building vast agricultural deltas, and central fault lines trapping estuarine flows. India's rivers are the active, flowing translation of deep tectonic history, constantly shaping the geography and economy of the landmass they cross.